and welcome to the last video. We're going to look at an exercise on momentum and impulse. This time we have a force time graph, and we're going to have a look at what kind of information we can get from this sort of graph. Now let's have a look at the exercise. A 5-kilogram object moving east at 10 meters per second experiences a force as depicted by the graph below. So we look at the graph and we have force on the y-axis, that's number 1 to identify, and time on the x-axis. And we see by the blue line how the force is the size of the force is changing with time. For the first 2 seconds increases up to 40 newtons, then for the next 3 seconds remains constant and then drops to 0. Now the first question is, we need to calculate the impulse imparted on the block, and question B, what is the final velocity of the block when the force dropped to 0. So the only information we get from the description of the exercise is that the mass is equal to 5 kilograms and that the velocity in the beginning is equal to 10 meters per second. Okay, so we have an object here, mass m, moving with the velocity of 10 meters per second, and then we have force F applied probably in this direction. We'll see how we can determine that a bit later, and then this will force the object m to acquire a new velocity, which we need to calculate at question B. Now for A, to calculate the impulse, just to remind you very quickly the formulas that we have for impulse, we have that impulse is equal to the change in momentum, which could be written as m times delta v. Okay, I remind you that momentum is defined as the product of mass and velocity. So change in momentum is the product of mass and change in velocity. Or we also saw that this one could also be described as the product of F, force, and change in time. And I want you to pay attention to this one. Now if we look at the graph, force, I repeat, on the y-axis and time on the x-axis, what sort of information can we get from a graph like this? So if you recall the motion graphs that we saw a few videos back, we were getting information either from the gradient of this graph or from the area. Now if we look at the gradient, the first 2 seconds, then the gradient would be defined as y over x, so it would be F over t, force over time. This gives us nothing for our level. But what if we look at the area? Now the area of this graph on a force time graph, the area is going to be force times time, because that's what we have on the y-axis times the x-axis. Okay, but now force times time is going to give us the impulse. So we can say that on a force time graph, the area will give us the impulse. So basically what we have to do for A is calculate the area of this shape here. And you can either do it as 2 different shapes, so a triangle and a rectangular, or you can also see it as a trapezium, and that's what I will personally do. So we have a trapezium, which we know that its area A is going to be the large base plus the small base times the height divided by 2. So on this one, we have this side, which is equal to 5. We have this side, which is equal to 5 minus 2, so that's a 3. And then the height is going to be 40. So if we replace this on this formula, we're going to have 5 plus 3 divided by 2 times height, which is 40, and that's 80 divided by 2 times 40. I hope I'm not making any mistakes, so please stay with me and let me know if the comments if you spotted a mistake. So that's 4 times 40, that's 160, and that's the area. So the impulse is going to be 160 newtons per times seconds. So the area under the graph. Now we also want in question B the final velocity. Now the moment you hear final velocity, you should think of change in momentum, because the change in momentum has the initial and the final velocity. So if you go on these expressions here, we have that the impulse is equal to change in momentum, so this m times delta v. So you can say for B that impulse is going to be m times delta v, and you can rewrite delta v, the change in velocity, as the vf minus the v initial, v final minus v initial in the beginning. And this is going to be equal to 160. Now the mass is given as 5 kilograms and the initial velocity is given as 10 meters per second. So we have that 160 is equal to, I forgot the mass, 5 times times VF, which is what we're looking for, minus 10. And this one, to work this out, what we need to do is we're going to divide both sides with 5, and then we're going to have 160 divided by 5, which is going to be 32, equal to VF minus 10, and then you subtract 10 from both sides, so 32 minus 10, no, you add 10, oh, pardon, you add 10 on both sides, so VF is going to be 42 meters per second. Now what's this? Question is about the final velocity, not speed, velocity, which means we need direction. So this is 42 meters per second, and that's the magnitude, and the direction is east. Why? Because we ended up in question A calculating a positive impulse, which means positive impulse means that the force had a positive impact on the mass, which means it forced it to be accelerated to this direction, to if this is the east direction. So positive impulse would mean that the speed, the velocity needs to increase and it has to go in the same direction. So the final velocity is 42 meters per second in magnitude and in the east direction. So this was a nice exercise where we only get information from the graph basically, and it reminds us of the motion graph, the discussion that we had a few videos ago. So I hope it was helpful. Let me know in the comments, first of all, if my calculations were correct and if you have anything unclear on this topic.